Good afternoon and good morning to everyone on today's Ranger 4 webcast. Today we're going to be talking about making production-like test environments. My name is Helen Beal. I'm the Head of DevOps here at Ranger 4, the host of today's webcast, which will be delivered today by Nick Blamey, one of our colleagues in the IBM Software Group. So over to you, Nick.
Fantastic. Thank you very much, Helen. So just to introduce myself, I work within IBM Software Group, and I'm responsible. I work in a team of sales and pre-sales guys, looking after one of the most exciting acquisitions that IBM's made in the last 20 years. The acquisition is a company called Green Hat. I'll talk more about the acquisition in a while, but just to fill you in a little bit about myself, I've been in this testing space for just coming up to 20 years now. I've watched the testing space evolve from client-server testing in the 90s, moving into the web area, load testing and those kind of things. I also had short stints in security testing. One of the biggest challenges around in the whole of the testing area is making production-like test environments. And this is the main reason why IBM acquired a company called Green Hat around just over 3 years ago. It's the most interesting innovation in the testing area. It fixes a lot of these challenges around making production-like test environments, which is the focus of our webinar today. I'll just go through a little bit about Green Hat first. So it was a British startup. It was a group of individuals working in the investment banking area, and they were basically middleware consultants and experts in deploying middleware for mission-critical applications. What they basically realized whilst they were engaging with major clients is that the largest cost and risk to a project was the testing of that middleware. And they saw a huge gap in the market to improve that testing. And they built this capability over the last 11 years. And that's the focus of the Green Hat product. It's recently been rebranded as Rational Test Virtualization Server and Rational Test Workbench. And it's seen as the most successful acquisition that the Rational brand within IBM Software Group has ever made. The structure of the presentation today, I'm just going to give you a very short overview of Rational, the component of IBM Software Group, and how Green Hat fits into that suite of solutions. And then I'm going to go through a structured presentation of how you can use our capabilities to build these production-like test environments. So just moving on to the next slide. Excellent. So this is an overview of the full suite of IBM Rational products. We have capabilities which span the entire software development lifecycle. So in the top left-hand corner of the box in the middle, the kind of oblong box in the middle, portfolio management capabilities for measuring and monitoring the state of your software development projects, enterprise architecture products. And then IBM has acquired 3 different companies, which then gave us the different stages of the software development life cycle. So from requirements to the high-level design, detailed design, UML modeling, coding, building your applications, testing them, and then deploying them. And I don't want to spend too much time on this, but obviously we're going to focus very heavily on the testing stage of the software development lifecycle. IBM acquired various acquisitions, of which the testing is the focus for today. And about 5 years ago, we realized that the biggest wastage in the software development lifecycle was the linkages between these different stages, the kind of silos between the different areas using requirements tools, the developers coding their products, and the testing phase. So IBM re-architected all of those products about 5 years ago to plug into something called the JAS platform. So you can think of the JAS platform as kind of Bluetooth for different products throughout the software development lifecycle. So regardless of what you're using to store your defects or what you're using for designing your applications, what you're using for coding, you can plug all of those applications into the JAS platform, and it will basically allow you to fine-tune your software development lifecycle. So it will tell you very interesting things like what percentage of defects you have in your defect tracking system which were caused by ambiguous requirements, or what percentage of unit test errors were caused by inability to create production-like test environments. The JAS platform will allow you to mine that information. So I just wanted to give you a quick overview of that. Let's now focus in very much on the testing area. I want to use this diagram, this photograph now, just to give you an idea of the way testing is currently being done. So if you think of your very mission-critical application that you're building and testing as a supercar, in this case it's a McLaren supercar, the way you basically test it is you build a prototype, you plug all the pieces together. So in the case of this car, if you think of the engine as kind of maybe the database or the application servers, and the steering wheel is the graphical user interface, you build the whole prototype. You then hand that car to the testers, or in the case of the supercar, someone like the Stig from Top Gear for all you petrol heads, and he would basically take it around the track and try to blow it up and try to sort of break it. Then a very long process is gone through, then trying to triage exactly where the problem was. You take the car, you put the fire out, you take the car back to the pit. Everybody sits there with their clipboards trying to work out where the defect is. Very expensive, very time consuming. And eventually you may figure out where the problem was. That's the kind of current state of the testing process and how you build your test environment. If we look at this graph here now, this kind of illustrates this from a defect management point of view. So if on the left-hand scale, we've got the beginning of the software development life cycle, and obviously you have your go live and end-to-end test and production at the right-hand side. That's the end of the project. Most defects are found very late in the development cycle, and that spike in defects, as you go through various testing cycles, you slowly eliminate the defects, and at some point the business allows you to go live, probably with a number of defects still in the solution. A lot of that cost in that peak is also created by the inability and the expense of having to create production-like test environments, and this is an area that obviously is the focus of our presentation today. So the next picture I'm going to use, if any of you are interested in kind of petrol head oriented stuff, if you Google how to build a supercar plus McLaren, what you'll basically see quite late into the program, it's a kind of an hour-long program, is the way that they test McLaren supercars now. So they've already found most of the defects way before they built the prototype. So they've already tested the throughput of the carburetor, the engine at 8,000 revs for 24 hours. They've already done most of that stuff. All they're doing during the end-to-end test is literally fine-tuning. So in this picture, you can see the test driver has a laptop next to him. Most of the defects have already been found. He's literally just trying to take the engine to its absolute limits, try and do some fine-tuning of little components. But most of the defects have already been found. A lot cheaper, a lot more sustainable. You can they can build the supercars prototypes and use them again and again, and they're just tweaking and tuning the supercar before they go live. So again, looking at in the software development lifecycle point of view, what we can do using service virtualization and making more efficient production-like test environment is it allows us to basically flush out defects much earlier in the development cycle. So our end-to-end test becomes much more of an assurance exercise. We're not really finding fundamental defects anymore. We're just fine-tuning the application. And that has a fantastic return on investment, which I'm going to go through in a bit more detail. So the challenges which most of you guys are probably facing as you build applications are listed here. Obviously, most organizations are trying to do things around mobile. A lot of organizations will have a very complex ecosystems of kind of IT suppliers. I've seen situations where you have outsourced development, outsourced testing, outsourced even infrastructure. Some organizations even then outsource the project management function. It's a very complex ecosystem. A lot of our clients, the business is demanding that they're more agile. Stakeholders are putting their oar into the project, changing requirements constantly. There's drivers around, you need to find defects much more quickly, and that's particularly relevant when an organization, if you're responsible for a particular component of it and your organization is buying third-party components, that you can isolate defects in those third-party components, and the third-party components are not breaking your finely tuned supercar or software development application. The other thing that we're seeing in the market is obviously there's an escalating cost of quality. A lot of organizations are offshoring testing to offshore, cheaper locations, but the wages in those countries are now increasing, which is also putting pressure on and extra challenges on the testing process. Now I'll just start now and explain a bit more about what service virtualization basically is and how we can create these production-like test environments. So traditional testing focuses very much on the graphical user interface at the top of there, where the penguin is sitting. Obviously, you'll do things on the graphical user interface, which will then send off messages all around a very complex IT infrastructure, middleware layers, third-party components, maybe anti-money laundering systems, payment systems into the cloud. Messages will come back and then they'll manifest themselves as defects on the graphical user interface. But it's the isolation of those defects in that complex infrastructure that's very important. Just to create a production-like test environment, just like this simple one here, where you've got obviously a database in the middle and various sort of web servers, app servers, is very expensive. Once you've created that production-like test environment, you end up with contention issues where load testing people need to share the test environments with functional testing people, and you'll end up with contention where the load testing people will dirty the data and that has to be reset, and the functional testing people are trying to work over the weekend and they need the data reset. All sorts of cost, effort, risk involved in making that production-like test environment. This is a typical WebSphere example. Ranger 4 are a premier WebSphere partner, so we thought this is quite relevant here. But this is a typical architecture diagram that some of you testers may get involved in. Maybe links to Software AG web methods or SAP systems, an IBM integration bus in the middle. Each of those components sends messages based on things that happen on the graphical user interface. So what we need to be able to do is, for example, if the SAP system is not online at a particular point or is being upgraded, we want to be able to mimic ABAC transactions going into that SAP system. And this is exactly the capability of creating these production-like test environments, which IBM is showing you today. Just before I sort of crack on with the actual details of how we do this, I just wanted to give you an example of the kind of return on investment which our solution can actually give you. At the top here, so in the graphic in the middle, you can see the cost of finding a defect during an integration test, as all the components are brought together, and then a system test, and you go through a kind of user acceptance testing and then operational acceptance testing. The cost goes up at a massive rate, and what a lot of our clients will experience is what we call a big bang at the integration test phase, when all of the components are all brought together. Just by moving the defects to the left, finding them a lot earlier, this is how we build up our return on investment, and is the reason why it makes sense and is valuable to your organization to make production-like test environments. So the other concepts which I just wanted to go through is, this is maybe a typical challenge which a lot of you testers will be experiencing at the moment. Obviously, the business will define a set of requirements. They'll be built up and coded. Developers will write their own unit tests whilst they're doing that. As I mentioned before, then we get this big bang. Then we go through a system testing process, which tends to be where the testers actually get involved. They're obviously final quality gate, marking the homework of the business analyst, the developers doing the unit tests, and people bringing all of the applications together. Performance testing can't really start until very late in the systems test cycle. That produces quite a lot of business risk into your software development life cycle. And then obviously user acceptance test is the final set of tests done against it. And again, that tends to start exceptionally late. That tends to create this large risk and cost. It is even worse without the ability to create production-like test environments using technology like IBM offers. So obviously, you tend to get the situation where multiple defects are introduced at once, and that creates risk into the projects and gets incredibly expensive. So what our capability allows you to do is, whilst the developers can create unit tests much earlier in the development cycle at that middleware layer, we can eliminate that big bang and begin our integration test much earlier. The system test process can literally be minimized to almost nothing, and performance testing can literally begin as the first pieces of application are built. Developers and testers can work together to bring their own components under load much earlier in the development cycle. And this is particularly relevant where you have third-party components being bought. A lot of third-party components will make claims about their applications that this anti-money laundering system or this payment system can handle this much throughput per second. By finding out those performance issues and bottlenecks a lot earlier, we can bring the performance testing much earlier in the development cycle. And this basically shifts the user acceptance testing and operation acceptance testing to earlier in the dev cycle. And it also allows testers to basically get involved in the testing process much earlier in the development cycle. And for any of you testers who are contractors, obviously that's much more interesting to you. You can begin working and helping with your customers and also billing your customers much earlier in the development cycle by using service virtualization to make more production-like test environments. I just now want to go through in a bit more detail of how this technology actually works. So the first thing, when we begin recording these messages to create these production-like test environments and effectively create stubs, the first thing we can do is look at the payloads, create and send payloads, and we do this using recording technology. On the right there in the box, you have an example of a Swift message. Now that message, to me, I'm not technical, looks like complete gobbledygook, but to a Swift £1,500 a day guru, it obviously makes sense. But what we can do, the first stage of our recording is to basically take that payload and use a formatter. So we can take that very complicated, exceptionally difficult to understand payload and turn it into something a little bit more readable. So using the schema and the payload, we can format that payload into a much more robust and readable and maintainable kind of overview. So all of our messages, regardless of whether you're recording SAP messages or IBM MQ message broker or WSDLs or WADLs or whatever middleware, microservices, all of them will be displayed using the format in the same standard way. The next thing we can do is obviously create a schema to then use that formatting. So people will send messages via SOAP or maybe Swift, WSDLs. Our capability supports all of those. So this is how we can then create a set of tests which exercise using that schema, take the payloads, use the formatter, use the schema to then create a series of unit tests which we can then automatically convert into stubs. The next thing we can obviously do, because we've formatted and we've used the schema to analyze the payloads that are being sent, we can then do very clever things with the test data. So we can mimic different types of data going into your system, and this is where we can, as part of the concept of shifting the beginning of the testing earlier in the development cycle, you can begin using just testing type data management tools, even Excel, to begin firing all sorts of complicated test data at your application without any need to wait for the graphical user interface. And then the final concept of building up these integration tests is to use our transport, which is obviously how we're going to fire the tests into the application on the test. And these are just examples of some of the transports that we can actually use. Now, just moving on to the concept now of creating production-like test environments. I'm now into the sort of detail of how our capability works. On the graphic there, you can see an overview of the architecture of the application. So we have 5 different web services here on the left, and they're all pointing into the MQ message broker queue. What we can basically do is, this is our architecture school, so this allows us to use and work out exactly where we're going to record our test. So in some cases you may record for an individual WSDL on the left-hand side in those 5 boxes. At some stage you just might want to record every single message going into the MQ. This gives the tester the first overview of the architecture of the application. And with a lot of clients, we found all sorts of fundamental defects and problems in the way that applications have been designed. With testers, it's always interesting to know when you're doing graphical user interface testing, where are the messages going that you're actually firing into the system, and this capability of understanding the architecture allows you to really see where some of those messages are going. We've had certain clients who've literally testers who didn't know that certain applications were sending messages into certain queues. This is the first kind of way that we use the technology. We can record at any stage in this kind of architecture. The next concept I just wanted to show you, our recording technology will record both XML, SOA, WSDLs, MQ message broker, software AG, web method. All of the messages may be flying around all over the place. In the top right-hand corner, you can actually see different types of messages all being recorded. And this is our kind of development environment for creating the tests. We can then use these recordings to create our unit tests, our integration tests, and then convert those into stubs. And the next thing that clients want to do, they tend to spend as part of the software testing lifecycle when code is shipped from the customer. The first challenge that a lot of testers need to grapple with is to make sure that all of the interfaces, all of the different components of an infrastructure are all working correctly. A lot of testers will call this either a dry run or a smoke test. So what we can do is, using those recordings, automatically create a suite of tests which make sure every single component is actually working before we begin our end-to-end test. And this is very it has a huge return on investment. Typically, in a 3-week testing phase, a lot of our clients who we talk to will spend at least a week just proving the environment, doing that dry run, doing their smoke test, and making sure the components work. The first massive piece of value that we can deliver into your software testing process is to automate the process of that smoke testing. When we come to actually execute those tests, we can see here we're executing a suite of tests, and we have various defects there marked in red. So this is where particular unit integration tests are failing. Now we can take those failures and log those into whatever defect tracking system you're already using. Obviously, the IBM Rational Quality Manager is the best solution on the market. But regardless of whether you're using any commercial tool or open source products, we can pipe defects directly into those, which will then form part of your workflow for fixing integration test defects. And then this is an example of one of the reports that obviously we would create. We may, with certain clients who may have sort of hundreds and hundreds of web service interface links to third parties, we can instantly create these very detailed reports of exactly what went wrong. And the capability that we have, it doesn't just perform functional testing against those interfaces, it actually measures the performance. So as you can see there, it's got a start time and an end time, and you can actually set thresholds. So if somebody's tweaked something, or a developer who thought he couldn't have possibly broken anything by changing a little piece of code, we can actually log defects based on performance, of how long it takes for the transaction to go into the system, and how long it takes for that for the response to come back and verify that response. And then what we basically end up with is, after we've created all of these integration tests, we can automatically convert those integration tests into stubs. So what you can see here is, on this interface, we have a certain set of stubs, and we have both a live system, so more of not a live system, more of a test system, or we can then switch stubs on and off. So what you can see there in the middle under pcat, we've got the off the stub, and that is being satisfied by an actual stub rather than the live system. This is where we begin to, if components are not available, or components have a cost per test transaction, for example, an anti-money laundering system, or fraud detection system, or a payment system, this is where we can begin switching those stubs on or off, depending on what the testers want to do. And this is where we can begin creating our production-like test environment, but also eliminating a lot of the pain and cost of resetting and tinkering with test environments, which is with modern applications becoming much more difficult. In the column there with all the pluses, you can see that the testers have created new stubs, which is evidenced by the fact we've got that green cross, which means there's new stubs available for those particular components. So as you go through the process of creating unit tests and publishing those unit tests, this is where we can switch those stubs on and off. So this is how we're literally beginning the process of mimicking production-like test environments without actually having the need to have those test environments available. And I want to just talk quickly about some of our customers and what kind of return on investment these customers have actually managed to achieve. So Royal Bank of Scotland, who presented a few years ago, head of middleware for RBS Markets, Stephen King, at our user conference, he managed to become compliant with applications and reduce various fines which the bank were experiencing back then, or may have experienced, by around £5 million. Another example of the kind of benefits that they achieved: a 95% increase in project delivery, cost reduction of 63%, and this is in these creation of these production-like test environments. And they were able to reduce regression testing from a 4-week to a 1-hour process. So these are the kind of benefits. As I say, I genuinely believe that the service virtualization and the ability to create these production-like test environments is going to be the next piece of innovation which testers and anybody involved in the software development lifecycle needs to embrace. I'll just go through very quickly some of the other intangible benefits, which again may be some of the reasons why, when your boss is asking you why you're investigating service virtualization in a bit more detail, you can explain to them some of these more intangible benefits which aren't quite as quantifiable. So a lot of your developers will already be creating, before they send code to you, their own stubs, and a lot of people use SOAP UI and open source capabilities to do that. The stubs which are created, obviously using programming method, require an awful lot of subject matter expertise. They have to be hand coded. You can record using open source messages, but it's then very, very time consuming for experts in middleware to then program verifications on the responses coming back. And there's no automatic verification. So the first intangible benefit is the creation of production-like test environments through IBM Rational Test Virtualization Server. It gives you the ability to create a standard way of creating those stubs and those virtual services. And obviously, the second point there, we can actually enhance the tester's ability to use a test environment by using service virtualization. So that our capability can actually extend that testing window that you may have a very, very short time. If you've done some of your testing earlier on, prove the environment, and can perform integration testing much earlier, it grows the amount of testing you can do in a very limited time environment. As I mentioned before, another intangible benefit: a lot of organizations, before they begin their testing, they need to spend a lot of time doing smoke testing. And again, we can eliminate an awful lot of that cost and effort and risk to a project. And particularly with clients who are using offshore or managed test service to deliver testing, we can basically eliminate a lot of that cost. We can even get to the stage where we can execute batch files and use very complex data and set environments up using the creation of production-like test environments before functional testing even begins. And this, the last slide one of the last slides I was just going to run through. A lot of clients, as we do continuous delivery and more agile and DevOps-oriented testing, with builds of code coming very quickly from developers, being built, being packaged up, and then moving into the test environment. The ability for the testing organizations to be able to keep up with that speed of delivery is very, very important. And again, the service virtualization and the ability to create these production-like test environments is a very important component of the tester's ability to keep up with that. Another, I guess, for some of you are now approaching this very complex task of trying to keep up with continuous testing. These are some of the bottlenecks you may experience, or components haven't been delivered yet, or the business may not have even decided which maybe single sign-on application they're going to buy, which ESB, which fraud detection system, etc. These decisions may not have even been made yet, which can limit the ability for the testers to get involved and begin their testing process. And obviously, with regard to things like third parties, as I say, third-party component suppliers to your organisation are not always 100% honest with their capabilities and what they've actually tested against, and an awful lot of time and effort is wasted by the testers, together with the developers and the third parties, triaging where defects lie in very complex infrastructures. And by using service virtualization and being able to create your own test environments, we can eliminate a lot of those costs. So Helen, that was pretty much my overview. I think I've hit exactly the time, so I guess we're open for questions now. I don't know if you wanted to summarise.
We are, and you have absolutely hit us at 30 minutes on the button, so thank you very much, Nick. And yeah, as the conclusion of your presentation, came to there is this is a really important part of continuous delivery and being able to continuously test, and important part of what we're trying to deliver when we're doing DevOps. So we do have a number of questions. I don't know if you want to just kill that alarm. So the first question is, how long does it typically take to set up a stub initially?
Well, that's a great question. I guess I'd answer that in a couple of ways. If you're setting up a stub and you're using developer effort to do that, that can be very time consuming. Working on the definitions of what the stub's going to look like, what kind of responses are going to come back from the stub, that can be very time consuming. In terms of how long it takes with our capability, what we basically do is we install on something like MQ Message Broker at production level ESB or TIBCO or WebMethod, we install an agent, and what that basically gives us is ultimate power over that ESB. So we can fire messages in, we can watch the responses coming back out, and the creation of the stubs is literally a point and click. We've seen situations where it will take an organization or a set of developers working together maybe a day to create quite a complex stub. We can do those kind of tasks in a matter of, I wouldn't say seconds, but maybe more minutes. And obviously, for any of you who are interested in taking a more detailed look at this, then Helen and the Ranger 4 team would be very happy to talk to you about an evaluation or more detailed demonstration. We can actually prove how quickly we can create those stubs during that WebEx session.
Absolutely, or a POC or whatever. And another question is kind of related, I guess, but what's the time to value of our TVS? I.e., how long is it from installation to having a working environment?
Well, that's another excellent question. Very return on investment oriented. Very impressive that the audience is thinking about the demands of the accountant. I'd suggest that the first snippet of the return on investment is around the fantastically quick where we can create those stubs. So more the answer to the first question. In terms of the next stage, by creating a series of integration tests, which again is all done by recording and point and click, we can produce a really good return investment and time to value of this proving of the test environment, making sure every single component is working correctly, and that can be a huge benefit. So I've seen organizations who spend literally of a 4-week test cycle, over a quarter of it just making sure the test environment's working. And then in terms of once the stubs are all working, because we're finding defects a lot easier and we're not testing as a bottleneck because there isn't production like test environments ready, it's quite difficult to quantify how quick the time to value is. But I would say if you take a look at the number of defects that you've got logged over maybe a 12-month period in your defect tracking system, around anywhere between 10 and even 70% of it's a very pure middleware application, that those will be integration defects or defects which are problems with the inability to create production-like test environment. From those kind of metrics, we can build you a very interesting return on investment. And again, Helen and the guys at Ranger 4 are experts at helping you articulate that time to value in literally from investment to return on investment, literally calculating that to the day when you'd get that return on investment and giving you a way of proving that to your management.
Thanks, Nick. Just a couple more questions. Would you use this as well as or instead of a virtualized test lab?
I mean, what virtualized test labs give you that ability to do is spin up test environments quite quickly on maybe one large box, but it only takes one component of that virtualized, whether it's virtualized environment or a physical environment, to have some sort of problems with it, which is stopping your test environment working and eliminating your ability to actually test. So now, regardless of how slick you are in creating your virtual test environments, and I mean virtual VMware type, multiple machines on one box, you're still going to have integration defects. You're still going to need to prove the test environment, and you're still going to have component problems with all of the components that sit in that virtual box. And our capability is totally irrelevant whether you're spinning up the test environments very, very quickly. We can still work with virtual VMware and hypervisor type test environments. So I'd say the two need to be used in parallel. One interesting thing I'm seeing in the market now is that we have a lot of clients who are deploying test environments into the cloud. And the fantastic capability which service virtualization and our ability to make production-like test environment gives you, it offers a way for testers and developers to all test without the need to create VDI images or weird images of defect tracking systems or instances. If you put it in the cloud, then literally an ecosystem of third parties or offshore developers can begin testing on your kind of production-like test environment in the cloud. So what people call that kind of tester or developer sandbox.
Great. I did say 2 more questions a minute ago, but we've actually had another question, so still 2 more questions. Here's your penultimate question currently. What do you do if you have an application that can't be virtualized, in the sense that the business won't accept it can be virtualized?
I mean, again, we are definitely talking about service virtualization, so integration layer virtualization. Nothing to do with you know, hypervisor and VMware type virtualization. Just to be clear, we're talking about message layer simulation or virtualization. I think the market and the IT industry has given the name service virtualization. Another way of putting it is service simulation. So we're simulating web WSDLs and web services and message layer technology. I've never come across a time when the business will not allow you to virtualize a component, because we're basically talking about production-like test environments. We're not so limited on the there's less compliance issues because this is not live production data. And I'll give you a couple of examples. And we have obviously banks and retailers and telcos who are using our capability, and they're under massive compliance pressure, and they have all sorts of auditors looking at what they're doing. If we can, using service virtualization and our ability to create a production-like test environment, we can stub out things like single sign-on. So we can stub out every time you send a message to a single sign-on system. We can let the testers basically create a stub which always reflects back a authenticated message back to the system. So the compliance and the auditors and the business people quite like that, because it basically means that they can you can perform load testing without real production load test data with usernames and passwords. So I haven't really experienced that as a problem. Again, just to be clear, we're talking about message layer testing. We're talking about pre-production environment. And the other comment I'd say is obviously the business always puts saving money ahead of, particularly in test environments, ahead of any kind of concerns they might have about virtualizing something. I hope that answers the question. I think I've got the question. I think I've understood it correctly.
Yeah, I think you have, and I think I've heard one similar, and I think it's when we've been talking about continuous testing, a kind of nervousness of handing everything over to automation, and we talk a lot about kind of doing things iteratively on a small scale and proving trust over time. But yeah, the important thing is, as you say, it's not actually a live environment that we're virtualizing, it's creating a test environment. And your final question at the moment, have you any experience using Green Hat in RTC personal builds?
In Rational Team Concert personal builds. So we have a lot of clients who, when you're using Rational Team Concert, at the end of your, as you go through you take your source code, check it back into Rational Team Concert, then produce a executable or a final build, and all the source code is compiled. You can, at that stage, in your developer sandbox within Rational Team Concert, begin firing unit tests against it. And developers, as this capability ripples from the testing organization collaborating with the development organization, it tends to start in the testing organization. Developers then do begin to embrace it and will start creating their own unit tests and integration tests much earlier in the development cycle. And IBM also has capabilities obviously around the release and deployment area. And we have a lot of clients who will, after they've created a release, will then automatically, as part of the release process, and it doesn't just have to be an IBM product, which is obviously the best capability, which Ranger 4 are very experts in this DevOps urban code area. You may be using things like Hudson and Jenkins, but we can actually have those integration tests, the suite of integration tests, load tests, functional tests, stubs even switched on and off as part of that build process. I'm not a big expert on RTC build myself, but if you can imagine, we have thousands and thousands of customers using the combination of this IBM Service Virtualization and the Rational Team Concert Jazz-based products. It would be great if the individual who sent that question through would contact Helen, because I think we could definitely help you even more if you've got specific challenges around that build process.
Yeah, Ben, who asked that question, just asked if you can reach out to yourself and Aaron, so I will send everyone a note out on that afterwards so we can follow that up. And that concludes the questions for today and our time actually as well, so that's good timing. Thanks very much, Nick. That was great. Thank you, everybody, for coming on the call today. And we'll be in touch with the recording and the slides from today, and just let us know if you've got any more questions we can help you with. Thanks, everyone. Have a great day.
Thanks very much.
Bye, Nick.
Thank you very much.
Bye, everyone.
Bye, thanks.
Bye.